So I just realized I was talking to myself with the mic muted for like 2 minutes. So I'm just going to say that. Let's go back. Let's say that, hey, everyone, Eyal here. Thank you for joining me. Yeah, so I was muted. So welcome back to my stream. It's going to be one of my coding streams. There is a comment here from Robert, which I was trying to respond to about concerts in Israel. I think that I am currently in the United States, but it's possible it's actually likely that I'll be in Israel later in a few months down the road, and maybe I'll talk to my good friends and see if we can perform somewhere that will be a lot of fun. It's possible we'll do that, so I'll talk to the amazing musicians I usually play with, and we can see what to do. So anyway, thank you for joining my stream. As I usually say, I'm streaming this on a bunch of different platforms: YouTube, Instagram, Twitter, Facebook. I'm going to try to bring comments up on screen whenever I can, which I cannot do on Instagram, so I'll read them out. But if you can comment, I'm gonna put it on screen. We can chat. This is gonna be one of my very nerdy streams where I'm gonna be learning and coding game engine related things. Usually what I do is about audio, music, plugins, stuff like that. But now I'm trying to explore a little bit of my interest in other things. But hopefully, for anyone who's interested in tech and code, this is going to be a fun learning exercise because there's going to be a lot of internals of making an engine involved in this. So yeah, so I see a lot of awesome people here. I see April here, who's one of my favorite new artists. You should check her out. She's doing anime music in Hebrew. It's awesome. It's so good. I actually covered one of her songs one day just because it's so good. So you should look her up, april.is.music. It's an amazing music channel. She has great songs. She plays bass really well as well. So it's really great. You should check it out. She does amazing videos too, like anime style videos. It's really good. So let's talk about what I was going to do today. So what I was doing in the last stream and a last couple of streams actually, is I was writing this wrapper around OpenGL. I'm going to go back to that. And around SDL and OpenGL. I still need I have a lot of learn about OpenGL. I only can do the basics. But the idea is, in what I'm doing is, there's a wrapper library. Let me get my head away from here. Here it is. So what I was doing basically is I was wrapping SDL with a bunch of common functions. For example, here I have a little test. This is like the full app that's using like this little wrapper library. And what this currently does is let's build this and run this. So you can see that it draws a moving triangle on the screen, right? It's animating. It's animating the alpha on the triangle. There's actually a bug here. I was sure that I solved, but I guess I didn't. You see that now it's going to draw in the wrong dimensions. Only when I move it, it's going to be fine. Not sure. I did something to fix it, and I'm not sure what it is that I did. Anyway, but yeah, that is that. And the way this currently is drawn, like it's not the best API that exists, but really how this works is that there's no includes to SDL or OpenGL in here, but there are a few abstractions. There's something that's called a shader program, and then I pass vertex array, color, shape buffer. Like these are all objects that I created on the stream. And also when I created the shape, I used something called triangle. This is my own class, right? That represents a single triangle. And then I have something called shape, which is basically a vector of triangles, right? And then it has there's all these like underlying implementation functions to call the OpenGL implementation. So this is where I was. And I will be moving forward with this. But before I move forward with this, there's something I did that was fun. I thought it might be fun sharing the process of doing this. So I went on the SDL Discord, which is a great resource to learn more about SDL. So I go there also to ask questions and discuss SDL things because I'm not that familiar with this framework. But I do want to use it. It is used under the hood here from behind my little interface. So when I went there was an interesting discussion about using a message queue. And I liked it. I was like, okay, I want to make sure that I know what I'm talking about. So I went ahead and in a few minutes, I kind of put down a very basic message queue. And I might actually just now post as an open source library. It's very useful. It's super simple, but I thought it might be fun to go over the last few steps that I'm going to do as I'm going to go over it. So this before I'm just about to release this as open source during the stream, probably. It's very technical. It's not very interesting, but it's just, the idea is that there's a couple of classes in here, which I'm just about to separate. One is the message queue. Let's call it EA message queue so that it says my namespace in it. Yeah. So why does the message queue exist? So there's two reasons. One is that many times there's an application callback. Like in SDL, for example, there is a callback that gets called by the app itself or by the OS itself, where it basically just loops an update call. So many times in some platforms you can call it yourself. Like you can have an int main, like I have here in my little app, int main, and you can run the thing. But many times it's a thread that gets created by the application. So the application, or the operating system. So the operating system creates the thread and then it calls you to do things. Or a framework. Sometimes the framework creates the thread and the framework calls you in a certain order. And usually that happens in the same thread, but you don't always have the control. So what I made this thing where it's a message queue that either runs on a separate thread or run on your own thread. So you have the choice to choose where it's going to be executed. And then there's a safe way to add different functions to be called. So let's explain how this is called. So two ways to work with this. One is, let's just encapsulate this a little bit before I'm going to clean it up. The idea is that, let's say I have a function. Function is just going to print that it's running. And there's going to be two ways to do this. One is going to be called, run sync queue. Sometimes on stream, I feel like I don't know how to code, but I do know how to code. I promise. Okay. I'm just checking to see that everything is working. Hopefully you all can hear me. Okay. So what's this? Everything's okay. Right. I need more screens. Like whenever I work, I like to have one screen, but the stream is the thing that, and I have two running now, and I'm like, I need like four screens to handle everything. Okay. So the idea is the sync queue is something that that is that, let's say my main thread is going to run the sync queue, and I just reminded that I might want to yeah, I just thought that I might want to encapsulate this. Yeah, but the idea is sync queue means that there is something called message queue queue. So the queue is there, and then we can add functions to it. Like we can do something like add func, right? So we can add not a call to func, but the func itself, right? We can add a bunch of those, and then we can just run the queue. So that's one way to do this. The other way is run async queue. This one's going to be more interesting. And this one is basically this. So let's start with the running the sync queue so you can see what this does. Right, so you can see it's called all the different functions, right? And this is important because let's see the way that run works. We're going to talk about the implementation in a second, but run just goes over these vector of callbacks. There's some protection there around threadings and such, and then it calls them, right? So it's just a loop of what I call callbacks, which is a vector of stood function void, which I typed def to be callback. So just a function, and we can pass the function to the queue and it runs it. And this is more important when you'll have something like let's say there's a timer that has been built, and you call run, periodically, like every second or every few seconds or every few milliseconds, and then you run, and then other threads are added, or this thread, but any kind of threads are adding different functions, right? So let's say something happened in your game, like a mouse was clicked, and you want, or maybe an enemy ran into somebody, and you want to send a notification to the thread. You call queue.add, and you send it, and then later it's going to be called asynchronously. So like if I'm going to stop here right now, and let's look at my console. None of the functions were actually run, so we just queue them, and then when we finish running, all the functions get queued. Async queue is more interesting because it spawns a thread. So it uses an object called message queue thread, and it spawns a new thread that's going to basically going to continue running this until the thread goes out of scope. So what I did was, just to simulate how that works, I made a bunch of waitings. So I'm running the thread, right? And then I'm adding a function, I'm waiting, I'm just sleeping in this thread, then I'm adding this and I'm sleeping, and the other thread is going to call it. So let's see how that works. So let's call run async queue. Async queue. Right, and you can see that it called it. And let's have a look at the timer again. Let's try it again. Running. So it took the sleep time to do that, but also if I'm gonna breakpoint on this func function, you can see it got called on my side thread 2, right? That's not the main thread. If we were gonna stop somewhere in the main thread, oh, I might have missed that call of the breakpoint. If I stop it, this is on the Apple main thread 1, right? But this function has happened later on thread 2, and that's why this object exists. So it's for 2 use cases of using a queue. So you might need the more raw sync version if you're kind of plugging this into a framework, or you want to run it yourself, because and the use case of running it yourself is actually really important, because there's actually these 2 use cases might actually coexist in the same app or plugin. One reason, like for the threaded version, is that you might use this queue to run like a complicated task, but you only want to run one task at a time. You don't want to spawn 20 threads. You want to spawn one thread because if you spawn 20 threads, it's going to just jam the whole system. But what you want is to have every function get called in order, which this takes care of, like it's going to happen, but never interrupt the main flow of the application. So it's really useful. The same thread one is very useful as a base layer, whenever you already have something like a timer or an app. So hopefully that makes sense. Okay, so now I'm just going to go through the process of just cleaning this up right in front of you. And somebody said on the YouTube comments that my dock is disgusting because there's a bunch of stuff here. I know I could probably remove some of the stuff. It's going to be hard to remove all of them. It's all the stuff that I use often. It's all like Visual Studio Code. Safari I can probably remove from here, right? But most of the stuff is like my commonly used stuff. It's going to be hard to make like a hard decision. Anyway, so the comment is C++, good times, enjoy. Well, thank you. Hopefully it is good times for me, at least. I don't know what it means for other people. Okay, so let's try to get a little bit productive. What I need to do is I'm going to go to my GitHub and open a new repository, and then we're just going to very quickly clean this up. I'm going to create a new public repository. Let's create a new repository on my GitHub. You should not be seeing that stuff. This stuff is boring. I don't know, see all the repositories on my account. So many repositories. So I'm just going to call it message queue. I'll describe it as a simple C++ message queue. That can run in a thread. Message queue. Yeah, a simple C++ message queue. It's called like this. I'll add a README because it's probably going to be needed. License is going to be something like MIT. I don't know if MIT is the right license for this, but what do I know about licenses? Okay, so what I'm going to do now, I'm going to clone my own project. I'll just copy the code from here. I probably will also just change it because it's not going to be exactly the same. Okay. So project is going to be, let's change the CMake file. It's going to be something like message queue. And let's see if I can plan something that's a little bit more portable in the way this is used. because what I want is the CMake file to, first of all, be very easy to link. So it's just going to create an interface library. It's going to be header only. And it also is going to build like one example optionally, right? Which so I'll need two things here. I'll need something like I can call this, I guess include, and let's make something like an examples. And include is going to have another directory in it called message queue. I'm going to explain why that is needed in a second when we're going to build the example. And the file is going to be in here. CMake file is going to be here. The CMake file would just need something like add library interface. An interface library means for CMake that it's just going to pass definition. So that is that it's just going to pass in the include directory to the user or any other settings, right? Because there's not going to be any source files, but I do want to pass in the include directory so that somebody linking against it, we're going to show that how that works in just a second with the examples. Yeah, so let's do something interface. Let's call this message queue, and then I'm just going to do something like target include directories into the message queue interface, and it's going to have the directory where we're in. And you'll see in a second how this resolves to a nice call. This is basically all that needs in the settings. I can go to this, the H file. I didn't actually do anything in the H files, so I am going to copy almost the full code in here. So this is really the code of the library. I might create a couple of files in a second. Maybe I'll call it by other name. I think I might call it Q. Let's do Q thread. Yeah, this is gonna be better. Thread. Yeah, I think those two will be good. So I'm gonna move all these to this because you might not need the thread. It's possible that it's not gonna be an issue for you. But the queue you're probably gonna need. So let's separate these. So let's move all of this part. Vector, I don't need IOStream, but vector and function all belong in the queue. And then the thread just needs to include queue in the thread and add a few little threading related things. This is queue, needs to close these braces. Good. All right, and now let's look at so the examples code. I just want two examples. So let's just make something like a CMake list there, and let's call something like a let's start with one is going to be sync, and the other is going to be thread. So these are the two examples. The examples will be built optionally. We'll see how that works in a second. But this is, I'm here. I'm just going to create an executable. One is going to be called sync with sync.cpp, and the other is going to be thread CVP. And for both of these, I just need to say target link libraries sync private and message queue. So that's how we are going to link them together. And one thing, this hopefully should be, hopefully it would pass the information of this include correctly, but we shall explore in a second. This is going to be not be here very shortly. So yes, and now I should be able to do add subdirectory include, and let's do something like build examples on, and then if this probably should be off by default, but I'll make it on for now. Then if build examples, also add the subdirectory of examples. Right, so we're going to optionally build it. That's because the users might not want the examples. So we'll see how that works in a second. Okay. Let's load this CMake file. Let's see if I screwed something up. Probably did. Oh, so this is message queue interface, not this. Very good. Okay, so that works. So I don't see message queue in the target because it's an invisible target. It's just something that kind of injects settings forward. Yes, good. So let's try to build one of the things. One of these is going to be, so let's see that I can build anything. So return 0. So let's build sync. Okay, it builds. Now let's include. It's going to be called message. So this is why I needed this like include path, because now I can have something very readable in my include folder, right? So once somebody has their include directory set, this is going to look very clean. Message queue/queue. I can also remove this include path and just put it directly. Just a common courtesy people do. I can move it one up. There's also a possibility. Maybe I'll do that. I'll think about this in a second. It's good, and it's going to look the same, essentially. But I would just have to make the include folder one level up. But now that I can do this, somebody can just do message queue, and then do queue add. Let's write a function that says running. Let's include IO stream. Now let's do something like stood cout running. Let's make it correct. Let's do, because I want to see a few of those. So let's just move this into a variable and just add this function. So I'm going to add this function a couple of times, and then I can do this queue run. Let's see if that works. Oh, missing semicolon, of course. Runs and running, right? So this is the sync example. This is all that's needed for this program. Let's have a look now at the async version. Also, I want to use my Clang format. Let's see that everything's formatted correctly. So I did bring in a Clang format file here. It's good. And for the async version, I already wrote it. Let's do something like this. Yeah, so I can just copy this thing into the threaded function. So same here, I need to include message queue, or here I need to include message queue thread actually, because I'm going to need this. And that means I can do int main. First of all, let's make this shorter. So let's do something like using queue equals EA message queue. I can just do probably using yeah, here's like using namespace EA message queue. No, let's not do this. Let's do using queue equals using queue. Is that good? Yeah, EA message queue. Or let's not do that. Let's do, first of all, it's a namespace, but also I need to do namespace. Yeah, I guess it's fine. Namespace queue. Then I can just do something like, I don't need this anymore. And I can just do queue. It's a little bit more expressive. Queue, and the function can just be written in line by something like func equals. It's a copy from here. It's IO stream. And this is the function. And yeah, and we can also do something like, just wait a little bit of time and then return 0. Sorry, let's run the thread version. The version has some waiting in it, right? Running. Let's call this running on side thread, so that people will see that it's on a side thread, and we can also debug this to see that first one is on the main thread, but the actual calls are going to come in thread number 2. So these are this is the amazing example. Maybe I'll just clean it up by doing this for index equals 0, index is less than 5 plus index, and then just do this thing in a loop. So that the code is going to be shorter and neater. So you see it calls out a few times and then finishes. I don't need this anymore. Oh, sorry, I don't need this anymore, the first one. Yeah, so I should get 5 calls. 1, 2, 3, 4, 5, and finish. Wait 5 seconds. Then we're done. Let's make this 3 seconds to make people less annoyed. Yeah, but this is the idea. The idea is that these are the very basics that are needed to use this library, right? So this is the example. I don't need this anymore. This is unrelated. And then let's write a few comments about this. So the comments are just checking that everything's okay in my world. Okay, everything looks okay. The world has not yet collapsed, I believe. Has it collapsed? Has the world collapsed? No, right, good. Okay. Anyway, what have we finished here? So this offers two separate ways to you can use either a sync queue that you run on your own thread, for example, using the OS event loop or timer, or you can use the included threaded version to spawn a dedicated thread. Example uses are just three. I think it's less CP. If you already have a thread or message loop, also as a simple was header only. And then the other one would be on a side thread. Separate thread. Maybe I'll remove the for loop from this example. Just and then calls would happen on the side thread. All calls would only happen here. And here I can just type this directly, so I don't need the namespace thing because there's only a couple of fuses. Messages are safe to pass from any thread, including from the callback. Good. Let's make it this initial commit. Oh, I probably need to add some CMake instructions. Oh, wait, what's going on here? Do I not have the git ignore included? Oh, I need my git ignore. That is important stuff. Let's copy some git ignore that I have from somewhere else. Right, so added git ignore file. We need that so that git won't include other irrelevant files in here. And I also need a couple of CMake instructions, and I probably need to explain to people how to run this, how to build this. So first of all, I might change this to off. So the default will have no examples built. And then I'm going to explain to people so to build the examples, you can use, I'm pretty sure it has to be 3, right? I'm not sure why it's auto completing this. Maybe it can be 2, I don't know. Two tags. So to build the examples, you can use CMake minus G. Xcode minus B, a build minus D. Or in Windows, it's like Visual Studio 17, 2022. Login directly against it in CMake. You can just link against this interface library. It's like CMake, right? So this should be something like target link libraries. Let's just copy what I did here. My app SQ, and then include either or thread. Okay, so updated README with build instructions. Let's make this separate. And made examples be off by default. Okay, let's see if this looks correct. Let's go to my, this is what I have. There you go. Look at the nice README. Hopefully this looks okay. Great. So this exists. Message queue. Hopefully it's going to be useful for somebody. All right. So now that we finished with this thing, this was just a nice experiment. I'm not even sure I need this, but it was fun to do. Hopefully that was helpful. Now let's go to the next thing that I need to do. Next up is I want to learn more. I think this is where again my my learning of OpenGL would actually need to be enhanced by the amazing knowledge of ChatGPT. And so let's explain what happened so far. So far, the way I've done this is you can see that there's a single shape here that gets passed. And then I just create it with create this shape. And I wonder what it needs to do when I have multiple shapes. So let's ask ChatGPT about this. Because right now I just have this one triangle. Oh, and the other thing I need to fix is the problem that I had with the window, which I could have sworn that I fixed already. You can see now this looks good after I move. Now I'm going to resize. It's going to jump to the corner. I was sure that I fixed it somehow, but let's have a look. I thought that actually ChatGPT helped me fix this. Let's see. What did I ask it? There's a bunch of stuff on how we set up the window, which are interesting. Or maybe I didn't solve it. Maybe I just observed it and I never solved it. So the problem is, and this is interesting, so the problem is, as you can see, I think I vaguely remember what I did. Yes. Oh, damn it. I thought I fixed that. It's so weird. I probably changed this. I forgot why. What was the call that I had to add to this? Yeah. So let's see if I can remember what I did to fix this, because I can't really remember. But I remember there's something about I had to do about the window itself. Because I do get this when the size gets created, but I think I don't do something properly. Maybe because I'm doing 0, 0. What is that? I should run get rebel size. Is that a thing? No, that's not a function. That's an imaginary, or maybe something that exists in the past in SDL. Because when I set the size, this actually sets it to the wrong thing. Let's see how do I go this thing set size. First of all, let's do something I did here with the setup that screwed up the this up. I wonder what it is. Maybe I'll take a look at what these other examples are doing. So let's take a look at the official SDL samples. There should be a couple that's using OpenGL, I believe, right? Let's see if I'm right about this. 0, 0 with height. That makes sense. Clear depth function. Maybe also need to set the projection stuff. Let's try it. Let's see what this does. I have no idea what this thing does. No, it probably just doesn't work. Okay. What are these functions? GL shader model? Oh, so there's like an SDL OpenGL function. Do I need to like this, for example, right? So I need to include this specifically, probably. Hopefully I won't have any collisions in there. Like if I just include it, is this gonna break my build? No, my build is still fine. Still buggy, but fine. Anyway, this should give me these functions, right? Or do I not have them anywhere in this case? Oh, so maybe I don't need this because GLAD might have these functions. So it's like GLAD shader model. No? So what do I need to get these functions? Interesting. It's so weird. I'm blacking out on what I did here yesterday to solve it, and I just didn't commit and forgot about it. What was that? I don't think it had to do with the projection matrix. But maybe I need the projection matrix. I mean, it doesn't sound so weird. Are those actual functions, like those projection matrix stuff? No. None of them actually exist here. Oh, maybe I need to include GLAD. So maybe I need GL. And one of these does not include the other? Question is, how do I make a hardware ID serial number changer? Hardware ID serial number. Can you explain what it is that you want to do exactly? What do you mean? What do you mean by changing the hardware serial number? Are you trying to make your computer appear as another computer? What do you want to do exactly? Like, is this? That's a good question, by the way. I'm just not sure what it is that the question is. Okay, so now I have all these like projection stuff. Is this building too, like, or is there a great collision here? Yeah, that's what I thought. So I think, does that mean that I don't need to have GLAD? What happens if I don't include GLAD? Do I really need to use this stuff, or can I just use it like this? Okay, so yep, making the computer appear is another. I'm learning C++ at the moment and on pointers. Trying to change my hardware serial ID. This is, I don't know. I mean, I don't know if it, I mean, maybe it can be done. I don't think it's so easy to do. I think I think these are all, you know, the actual hardware ID is like based on like a system, something the system gives you, like the operating system. And I don't think you can just change it. I think what people do, you know, when they do stuff like crack software, like if somebody cracks a plugin and they want to bypass the protection, I think what they do is they actually go and change the code that grabs that serial and makes it return. Like they don't even call it. They don't call it the operating system. Because I think it's very difficult to change that, but it really depends on what the method is that the software is using. Usually it's using something given to you by the operating system. So it's also, first of all, it's going to be different in Mac, Windows, Linux. It's not going to be the same. So it's not some portable code that you can use. But what you can do, you know, again, it depends, unless you're trying to, don't crack software, for fun, whatever. But if you could, but what people do in that case is that, when they crack software, is that they reverse engineer the thing and just bypass that operation. That's something that people do. I don't know if it's so easy to do that. Or at least, I mean, again, I'm not saying it's not possible because, but you have to read into the implementations of the actual system calls. So that's how people do this. So they read it in, like you can read, for example, what, you can open a few libraries and see how they get the serial number, and you'll see there's system calls there, and it's possible there's something you can do on the system level hacking to modify it, but I have no idea what it is. This is I'll have to read about it. It's not going to be a trivial C++ thing. Anyway, there's something here that was called, like, let's see exactly what ChatGPT was. Oh, can I compile this like this? Is that working as it should? Oh, it works, but it crashes because I think I needed that GLAD, this thing that I had there before. No, I didn't need to do that. So why did I remove just now? Yeah, this thing, GLAD load GL loader. So I'm not sure I was supposed to get the window without this GLAD thingy. Let's see how SDL did this thing again. Because I saw they were doing that in their little test. Are they using GLAD here? No, so maybe they're doing something else to open the window. Maybe there's an SDL version that does that. All right. Yeah, I heard of reverse engineering. I asked some good C coders and said you have to access the kernel. Yeah, again, this is a level of hacking that's not my specialty. This is, this is the kind of thing that people who crack my software are doing. So it's not my specialty. Like, if I would need to, like, it's not something that's obvious. It's really always dependent and stuff. Even if it's possible, uh, it's difficult. The question is, how long have I been coding? I've been coding now about 10 years. 10 years, I think, of pretty much doing that professionally. But I never cracked anybody's software. I just know how that works from seeing how people have cracked my software. And by the way, crackers of software, just to be clear, they don't do that stuff. They don't hack the kernel. What they do is something way more high level. They find the bit of software that calls system stuff and they bypass it. They don't even do that, right? Because it's like they don't need to fight, the OS kernels. They say they look for some bit of software that says get the hardware serial, and they say, well, instead of giving you the real hardware serial, we're going to give you some fake hardware serial, right? So they do something like around that. They don't go into the nitty-gritty stuff of kernels, because that's like that's just not a productive use of their time. Usually it's so interesting, the way people don't realize that all kinds of hacking and cracking, even though it could happen on that level, it's usually way higher level. Like, it's much easier to, keylog the part where you put in your password than to actually break in the server and grab the password. Like, it's much easier. It's so easy to put a keylogger on your system, or something that, like a page that makes you type the password and then you type it and then they get it. So that it's much easier to do in a higher level context, I think. And I'm not suggesting anybody does these horrible things. I'm just saying that these are how a lot of these hacks and cracks are done. Same with cracking plugins. Like, people will say, oh, well, your plugin checks the license every second, so we're going to bypass the check. There's never going to be a check, so that, we don't need to, or your plugin calls the server to do server verification. We're going to call our own server. Like, we don't need to crack your server. We're just going to make a fake server that always says that the license is valid. Something like that. Like, these are usually the methods people are using. True, but usually people are scared to download stuff now compared to before. I don't know. What do you mean by scared? Like, they're scared to use cracked software? I don't know. People are still using cracked software. I don't know. I don't know. People are doing stuff. I don't know what they're doing. I wish I could play you the music I'm hearing right now, but my stream would get taken off. I'm listening to this beautiful Bill Evans solo. So good. Bill Evans piano solo. So I'm wondering, I'm just looking at this example code. How do they create the window in here? Is there an actual example here? Not what I just did. I can open, not a test, but an example. Use OpenGL, because I think that's like a unit test. Let's ask ChatGPT about this. So, because in the previous version it did have, it seems like all these functions do not exist. All these functions like this in glad.h. If I include gl.h, I get collisions with glad.h. How do I do I resolve that? Okay, fixed function points which deprecated. That makes sense. Okay, then to provide modern OpenGL. Okay, so I don't need that. Move away from fixed functions. Okay, use shaders from transformation. I am using shaders. Okay, so it's I should not be using all these OpenGL calls, all these fixed functions. This is good. Resolving header collisions. Okay. I forgot what I was telling it for some reason. It's actually only you that suggested the fixed function. This function. I don't need them. What I need is for my window projection, etc., or viewport projection, etc., to look correct without moving the window. STL get rebel size, but I think that function does not exist as well. Function does not exist. Not exist in that's interesting. All right, actually I have to stop the stream right now. I might continue this later. Thank you all for watching. I'll be back when I